Let's talk about the metric system. There are two key parts of a measurement. We have the number or the value, and then we have the unit or the scale. So 20, the number, grams, the unit or scale. 193, the number, Kelvin, the unit or scale, and so on. Always, always, always put units after a number. You can't just say 20, 20 what, okay? So I like to say no naked numbers. All measurements need units. Without units, numbers lack meaning, okay? So you can't just leave a number, it needs a unit. No naked numbers. So what is SI? Well, it's the International System of Units. It's a set of units that's used by scientists all around the world, and it's so that we're using the same units when we communicate scientifically. So what SI units are used in chemistry? Well, your source for units is always table D on the reference table, but let's look at specifically those SI units. For length, it's meter. For mass, it's kilogram. For time, it's seconds. So these units are what are used consistently when we communicate scientifically. Again, the units you need to know in chemistry are in table D. That's on the front page of your reference table. Now, when we're talking about prefixes, what prefixes are used? We use the only ones that are found on table C. So those are highlighted here in this table. Those are the prefixes that you need to know from table C. So again, these are the only prefixes you need to know. Now, you may have seen this before, the conversion staircase. I personally do like it as a great tool. To set up the staircase, you can use table C to help you. Let me show you. So start with base units. Base units, typically it has one single letter, like meter, liter, gram, second, something like that. And then you can see that the first thing in the table is kilo, and it's up 3. So I go up 3 boxes from the base unit, and I'm going to label it kilo. You can see I don't have any other positives in that table, so I need to put the boxes there, but I can leave them blank. All right, then deci is down 1, put that down 1. Centi is down 2, milli is down 3. Now, if you wanted to put micro, nano, and pico in that list, you would have to continue to go down. So micro would be down 6, so down 3 more. Then nano down 3 more, and so on. Now, as far as what you actually need to know for chemistry, you have to know how to convert milli to base unit to milli, kilo to base unit, and base unit to kilo. So that is typically all that is asked. So let me just show you what that means. That means basically you need to know how to go from base unit up to kilo, and from kilo back to base unit, and from base unit to milli, and from milli back to base unit. Rarely, if ever, are you asked to do any other conversion. So if you can get solid on those, you will be in good shape. Let me show you an example. 4.12 liters to milliliters. So here's where I'm starting, because you can see I have liters to start. And I want to go to milli. So I need to move 1, 2, 3 boxes. So that moves 3 places, and see how I went this way. So what I do is I take this decimal point and I move it 1, 2, 3 places. I have to fill it in with a 0, and I end up with this. What about if you're going from grams to milligrams? So grams down to milligrams. Okay, again, 1, 2, 3 this way. So I move the decimal point 1, 2, 3. And then this is what I'm going to get. Okay, there you have it.